in order to take a look at how work operates and how it's connected to other forms of energy, we can use a simulation from PhET called Energy Skate Park Basics. In this, we can start by taking a look at how topics that we already understand can help us figure out what's going on. If I start with the skater in its normal configuration for the simulation, I release the skater and move down the ramp, up the other side. It's pretty clear that the skater is not making it up as high as they did before. And that's because in the options we have on the side, friction is turned up between none and lots. I'm not sure how to quantify that, but I'm pretty sure it's more than we want in terms of friction. So we're used to dealing with problems that no friction exists. So if I put the skater up at the top, click play, skater goes to the bottom, goes up to the other side, and at this point it looks like they're making it all the way back up as far as they were released. We can turn the grid on, and we can see that they were released at about the 6 meter mark. They get back up to the 6 meter mark over and over again, on and on. And we can use some topics that we've talked about before in order to describe why this is happening. We know that there's this idea of force, and that the force of gravity acting on the skater going down is trying to move them down. There's a ramp in the way, so the force, we're going to get a component of that trying to push them into the ramp and a component trying to roll them down or slide if there was no wheels. So that force is going to take some time to bring the skater down the ramp. And as you exert a force for some time, you get a change in momentum. Positive force acting on an object will speed it up. We can also take a look at that same idea of impulse causing a change in momentum when the skater goes up the other side. We know that forces can slow objects down if the force is working against their direction of motion. And sure enough, as the skater moves up the other side of the ramp, their direction we can say is uphill, but the force is directed downhill. And that means the force is acting against them. It's in the negative direction compared to their motion, and we should get a negative change in velocity if we looked at the impulse change in momentum equation. One big issue here, however, is that we don't really know how much time's going by. It's very difficult for us to figure out how many seconds it's taking the skater to get from the top down to the bottom, where the force changes from going with their direction of motion to against their direction of motion. So we want to get away from thinking about time. Using time is great for impulse and change in momentum, but when it comes to work, calculating this new quantity called work, we're actually going to need force and distance. How far the force, across which the force is acting on the object. Now, in the case of the skater, that force is going to be symmetric. On the way down, a force is acting in order to accelerate in a positive direction to speed up the skater, and the same force is going to be working against them as they travel an equal distance in the opposite direction. So force is going to have the ability to accelerate an object, and if that force over some distance is doing a thing we're going to call work, then it can also add or take away from the object's motion.